Why does AI sound most certain right before it misses? There is a moment when the model suddenly sounds like it has everything under control. The chat window speeds up, the wording gets cleaner, the bullets line up, and your shoulders drop because the system finally feels locked in. Then the miss shows up. It keeps the topic, keeps the tone, maybe even improves the structure, but the one instruction with real teeth is gone. The exception, the constraint, the earlier decision, the quiet do not that mattered more than everything around it. That is what makes this failure mode so easy to trust. Most people expect AI to fail loudly. They expect the bad answer to look messy, slow, confused, or obviously wrong. But a lot of real misses arrive with the opposite signal. The model sounds faster, the output looks cleaner, the interface feels calmer, and that calm is exactly what lowers your guard. You can picture the screen. The response lands a little quicker than usual. The paragraphs snap into a neat rhythm. The operator stops scanning upward to compare against the original prompt, because the answer feels like it has already done the checking for them. That is the useful clue. The system may not be getting more complete in that moment. It may be getting narrower. It may be leaning hard on one interpretation, one cue, one likely continuation, and dropping the rest of the thread because the chain is still moving. So the danger is not random slowness or some dramatic collapse. The danger is a burst of smoothness that sounds earned before it actually is. One missing instruction can pass through the next step looking perfectly professional. That should feel a little relieving, because it means the moment is not mysterious. It is a pattern. And once you can spot the pattern, the next question becomes practical. What is this chain actually carrying forward when it keeps moving? What is the chain actually carrying forward? The chain is not one memory. It is a relay. When a workflow keeps moving, the model is not carrying forward a sealed box called context. It is rebuilding a working picture from whatever survived the last handoff. On screen, that picture can look stable. The original prompt, a short summary, a tool result, a retrieved document, maybe a system rule sitting above the chat. But those pieces do not stay equally alive. They compete for space, timing, and attention. So what is the chain actually carrying? Some of it is obvious. Prompts, prior answers, tool calls, retrieved text, memory summaries. Some of it is quieter. The models guess about what the task now is, which rule seems most important, which earlier choice became the default path, which assumption never got challenged. That hidden layer matters, because the clean text you see is only the surface. The real state is the model's current weighting of what counts. Here is the trade-off the interface hides. A long chain stays usable by compressing itself. Rich instructions become short summaries. Tool outputs stand in for the full process that produced them. Earlier turns get collapsed into a few lines, so the next step can fit and keep moving. That is necessary under token pressure and time pressure, but compression is not neutral. A chain can preserve the topic, the tone, even the formatting, while slowly shaving off the one exception or decision that actually keeps the answer right. You can picture the miss. The user says, keep the tone calm, use official docs only, and do not change the pricing example. Retrieval adds fresh material. A tool returns a neat table. A summarizer passes forward, write a clear update with sources. The flow still looks coherent. The dashboard still looks healthy, but one live constraint is already fading. That is why context is better understood as a working picture than a storage bin. It keeps getting repainted from partial traces, and every repaint can subtly change what feels central. That is the relieving part. The miss is usually not random. It is a chain simplifying itself under pressure. With that map visible, the next question gets sharper. Why does the system often sound faster at exactly the moment its view has started narrowing? Why faster usually means narrower? Not smarter. Why does it suddenly feel smarter when it may actually be checking less? Because a fast answer often means the model has collapsed the problem early. You give it a task with 3 or 4 live constraints, maybe a tone rule, an exception, an earlier decision, and a current tool result. And then the reply comes back in a cleaner rhythm. The bullets snap into place. The wording gets tighter. The pause disappears. On screen, it looks like the system finally understands. But a lot of the time, what changed is narrower commitment, not deeper reasoning. In a language model, Speed and fluency can rise when fewer possibilities are still competing. If the system is still actively balancing multiple queues, it has to keep more of the problem alive. That usually creates a little friction. Softer wording, extra qualification, occasional backtracking. When one queue starts dominating, the model can move faster because it stops comparing as much. It picks the strongest looking thread and keeps going. In a moving chain, that winning queue might be the latest summary, the most recent retrieval snippet, or the most obvious instruction on the page. If that queue is good, the answer feels efficient. If that queue is only locally right, the answer feels efficient and wrong. That is why the failure is so easy to trust. The topic still matches. The tone still sounds right. The formatting often improves. But one active detail quietly drops out. Use the second file, preserve the earlier exception, stay under the runtime cap, answer for this channel, not the last one. The system looks smoother precisely, because it is carrying less checking burden inside the response. This is the usable second. When the output suddenly looks faster, ask what the model may have stopped revisiting in order to sound that clean. Surface quality is easy to see. Hidden state is not. So the operator check is simple, but non-negotiable. Do not judge the answer only by latency, polish, or confidence. Judge it by whether the original thread is still present. That reframe is a relief, because the smoothness stops feeling magical. It becomes a signal. And the next section matters, because context loss usually does not arrive as a loud collapse. It first shows up in a quieter form, where the answer still looks complete while one live constraint has already slipped out of view. What context loss really looks like in practice, the dangerous moment, is when the screen still looks correct. You ask for a rewrite, the model keeps the same subject, the same clean structure, the same confident tone, and maybe even sounds better than it did 2 turns ago. But one live instruction is gone. The exception vanished. The earlier decision got overwritten. The constraint that was supposed to govern this answer is no longer steering it. In practice, that is what context loss usually looks like. Not a wild hallucination. Not a sudden topic jump. More often it is a polished answer built on the wrong active rule. Picture a product team using ChatGPT to prepare a customer update. Keep the tone calm. Mention only events from the last 24 hours. Do not include the EU account, because legal is still reviewing it. A few steps later, the model returns a sharper draft. The topic is still the outage. The formatting is still right. The tone is still measured, but the EU account is back in the story. Or the time window quietly stretches to include older incidents. On the surface, the answer looks stable. Under the surface, the state that mattered has slipped. That is the hidden mechanism. The model is not losing everything at once. It is leaning too hard on the strongest visible pattern, and too lightly on the smaller instruction that actually determines correctness. The broad frame stays. The decisive clause fades. That is why people miss it. They judge the decision surface. Good structure, right vocabulary, smooth flow. Reliability lives in the hidden state. Which exception is still active, which earlier choice is still binding, which rule still outranks the rest. The cost is not just a wrong sentence. It shifts work onto the operator. Now someone has to recheck the one condition that changes the action, because the model can sound fully on track while carrying the wrong constraint. That is the silent trade-off. Clean output can arrive from a narrower internal picture. The useful reframe is simple. When the answer still looks right, inspect the clause that would make it wrong. That is only one layer of the pattern. The next section shows how the same compression keeps happening as a moving workflow squeezes the thread even further. How a moving workflow quietly squeezes the thread. The miss usually starts several steps before the wrong answer shows up. Picture the workflow on screen. A chat hands off to a summary. The summary triggers retrieval. Retrieval pulls in a few documents. A tool returns fresh numbers, and the next model response suddenly looks cleaner than the one before. What changed is not that the system understood more. It is that the thread got squeezed. Each handoff keeps the parts that are easiest to restate and quietly weakens the parts that were only important, because of their exact wording, timing, or exception. That matters because long chains do not carry the original task forward intact. They carry a rebuilt version of it. A summary is already a judgment about what counts as the point. Retrieval adds more text, but extra context is not the same thing as understood context. It can add noise, old assumptions, or nearby facts that sound relevant enough to steal attention. Then a tool output lands with fresh, concrete detail like a metric, a file name, or a timestamp, and that new detail feels authoritative. The chain begins leaning toward whatever is newest, neatest, and easiest to anchor on. This is how a small error turns into a large consequence. The model may still keep the topic, the tone, even the format, so the answer feels on track. But the original live constraint may be one exception in the prompt, one earlier decision in the run, one sentence saying, "Do not use that source," has now been compressed 3 different times. By the time it disappears, it does not feel like a dramatic failure. It feels like a smooth continuation of a slightly rewritten task. That also shifts work onto the operator. Now you are not just checking whether the final answer sounds good. You are checking whether the chain preserved the right priorities across summaries, lookups, and tool calls. On a dashboard, that can mean one polished output card sitting beside one buried missing condition that actually determines whether the result is usable. The first mechanism explains why the thread gets thinner while the system keeps moving. The next section matters, because once that squeeze is happening, clean output becomes exactly the thing that hides the failing metric. Why clean output hides the failing metric? The answer can look finished before the reasoning is. That is the trap. On screen, the model suddenly feels better at its job. The reply comes back quicker. The bullet points line up. The wording gets tighter. Transitions sound more deliberate, almost edited. So the operator relaxes, because the system now looks organized. But organized is not the same thing as aligned. Lower latency, stronger tone, and neat formatting are all signals on the surface. The thing that actually matters is hidden underneath. Is the model still carrying the one live detail that decides whether this answer is safe to trust? And here is the uncomfortable part. Losing that detail can make the output look better, not worse. If the model drops a constraint, an exception, or an earlier decision, the task becomes simpler to continue. There is less tension left in the prompt, less conflict to juggle, fewer moving parts to keep active at once. So the answer can sound smoother at exactly the moment the internal picture has become thinner. Picture a clean planning response in ChatGPT. You asked for a rollout sequence, and one condition mattered more than everything else. Do not switch traffic until the fallback path is tested. The model answers fast. It gives you polished phases, tidy risk notes, confident verbs, and a strong closing summary. It looks more reliable than the rougher answer you got earlier. But the single sentence that determines whether the plan is actually usable is gone. That missing line matters more than every polished sentence around it. This corrects a common misconception. People judge reliability by decision surface. Speed, structure, confidence, flow. Real reliability lives in state fidelity. Which requirement is still active? Which exception is still alive? Which prior choice is still binding this answer right now? Clean output is not the same thing as reliable reasoning. Extra context is not the same thing as understood context. So the practical move is not to distrust everything. It is to check one level deeper when the answer suddenly feels smooth. Ask what critical detail survived. That small habit lowers the operator's burden because it points your attention at the failing metric. And the next section matters because the same clean miss does not stay in one chat window. It starts traveling through longer AI workflows. What this means is AI workflows run longer. Watch a workflow run for an hour and the danger no longer looks like a weird answer. It looks like a healthy system. The agent updates the ticket, the dashboard stays green, the summary gets shorter and cleaner, and each handoff feels faster because less is being reconsidered. Then one small dropped fact, a refund exception, a channel cooldown, a do not send flag, keeps traveling as if it were still there. Nothing sounds wrong. Nothing looks noisy. The break only becomes visible when money moves, something publishes, or the wrong action survives long enough to become expensive. That is the practical future of longer-running AI. As language models move from one chat into agents, planners, schedulers, and multi-step production systems. The failure mode shifts from obvious nonsense to quiet state drift. The model can still sound aligned with the task, while losing the one live constraint that made the task safe. The silent trade-off is easy to miss. Longer autonomy buys throughput by turning more of the job into compressed working memory. That makes the system look faster right when its understanding is getting cheaper. So better AI workflow design will look less magical and more structured. Critical facts need to live outside the model in places that survive every rewrite. Ledgers, task state, checkpoints, approvals, retry rules, explicit fields, durable memory the next step has to read, instead of vaguely inherit. And every longer chain raises the operator's burden in a very specific way. You do not need to inspect every sentence. You need to know which facts are too expensive to forget, then make those facts mechanically hard to drop. This is why memory is not a vibe problem. It is a system design problem. Extra context still has to be interpreted correctly, and a clean dashboard does not prove that the right constraint is still active. The model may be compressing the workflow beautifully while compressing the wrong thing. This is the usable second. When a long-running AI system suddenly feels unusually smooth, do not treat that feeling as proof. Treat it as the moment to check whether the thread is still intact. That is the comma rule. When the model suddenly feels smooth, verify the thread before you trust the mood. Catch the moment before the feeling turns into a conclusion. The better rule when the model suddenly feels smooth, the risky moment, is not when the model sounds messy. It is when the screen suddenly gets elegant. The answer snaps into place, the bullets line up, the wording gets cleaner, and you feel your shoulders drop because it looks faster, more certain, more on track. But that is exactly the moment to get a little more skeptical. In a moving chain, smoothness can mean the model has stopped wrestling with the full thread and started gliding on the part it still recognizes. That is the better rule to keep in your head. Clean output is not the same thing as reliable reasoning. Extra context is not the same thing as understood context. A long prompt, a retrieval block, a tool result, a summary from 3 steps ago, all of that can still be sitting in the system while one active constraint has quietly lost weight. The topic remains. The tone remains. The formatting remains. What disappears is the one instruction that actually decides whether the answer is usable. Picture a dashboard where every field looks filled correctly, but one small policy flag flipped on step 4 never made it into step 7. Nothing feels broken until the action is taken. That is why the operator burden is not to admire fluency. It is to verify continuity. What question is the model answering right now? Which constraint is still live? Which earlier decision is it actually carrying, not just echoing? This is the usable second. When the model suddenly feels smooth, do not read that as proof. Read it as a checkpoint. Reopen the prior turn. Restate the constraint in one line. Compare the answer to the exact thing that mattered. If the chain is still intact, good, now you have evidence. If not, you caught the slip while it was still cheap. That reframe is relieving, because it shrinks the moment back to human size. You do not need to panic every time an AI answer feels polished. You just need one calmer habit. When it gets eerily smooth, verify the thread, not the mood. You notice the rush sooner, trust it a little less, and give the room a chance to stay the size it